All right. So, hello and welcome everyone. So, welcome back, all of you. Welcome to this amazing platform of TUT Learning. And today we're going to start with our new chapter that is going to be ellipse, right? So, this is a lecture number 1 on the topic of ellipse, right? So far we have been discussing with parabola and we already finished parabola. Before that, we have already finished circles and straight lines, right? So, I hope this journey of coordinate geometry has been quite good so far, right? So with this, we are left out with two more chapters, that is going to be ellipse and hyperbola, right? So this ellipse and hyperbola are very much related to each other. So therefore, it is quite good if we try to study those chapters step by step, okay, and one after the other, right? So what I mean to say is that after we finish off ellipse, we're definitely going to start with hyperbola, because the results in hyperbola and the results in ellipse are almost similar. However, they differ only by a negative sign, right? So that is a very important thing that we will see in soon in our lectures, okay? So with this particular thing, let us get started with ellipse, right? So today we are going to discuss about the standard equation of the ellipse. We're going to see how an ellipse is defined, and along with that, we're going to solve some questions regarding ellipse as well, right? And after we are done with our discussion on the basic, we will go on to solve some basic problems on ellipse as well, right? All right, so this is the plan of action for today's class. I welcome all of you, and if you're new to this particular platform, please subscribe to the channel and also hit the bell icon, because this channel is going to help you a lot, especially for your JEE Mains and advanced preparation. Okay, so if you are preparing for JEE Mains and advanced and you're currently in class 11th and 12th, and you can definitely follow this particular platform, and with this you can also keep on your preparation. Okay, so if you are also preparing for NEET examination, we have already our TUT Learning NEET platform where you can study the for your biology part, right? All right, so with this thing, let's get started. Okay, so today let us first begin with the ellipse. Okay, and the very first thing that I'm going to discuss today at the first is the definition. Okay, so let me define, or let me talk about the definition of an ellipse. Okay, or how an ellipse is defined, right? So if we start with the definition of an ellipse, the two thing is very important to know over here is that an ellipse is basically, so if I take, let us take 2 points, okay, let us say this is a point S1 and this is point S2, right? So these are two fixed point, okay, and we'll soon call this fixed point as focus point. Okay, now do one thing, you take up any point P such that this point P is having an coordinate x comma y, okay, and this S1 and S2 is fixed point. So what you can do is that you can do this experiment at your home as well, right? You can fix two pins, right? You can fix two pins and you can take one thread, okay? You can take one thread which is connecting this 3 points, okay? You can take one thread connecting this 3 points such that the thread is, you keep the thread such that the length of the thread remains the same, okay, but you can move this point P, okay, whereas this point S1 and S2 are fixed point, okay. So you keep S1 and S2 as fixed point and you try to move this point P, right? So if you do that, the kind of geometry that you will obtain is something going to look like this, right? So the geometry that you will obtain by completing this particular locus of point P such that this distance of point P from focus and the distance of point P from the second focus is going to remain the same. That means that if I take up any other point, let us call this point as P1 and this point as P2, and in this case this summation of the distances, that is P2S1 plus P2S2, would be equals to P1S1 plus P1 S2, okay. So this particular sum of the distance of the point from the focus, from the two of the focus, is going to remain the same, right? So if I keep this condition intact, the kind of locus I will obtain, so the locus of this particular point P I will obtain is basically that of an ellipse, okay. So the locus I will obtain is that of an ellipse, right? So ellipse is basically the locus of a point such that the distance, the sum of the distance of that point from the two of the focuses, that is the focal distance, okay, the sum of the focal distance is going to remain the constant, right? So you can do this experiment by fixing two pins at this one and S2, and you take one thread and you tie this thread with the pencil, okay, or a pen, and you try to keep the length of the thread constant and you keep moving or rotating your pen around the figure, right? Don't try to mess around with the length of the thread, right? So please make sure that the length of the thread remains the same. You just try to draw as the length of the thread remains the same, right? And if you draw it, you will see that this is going to be like a figure of this ellipse, okay? And this is how we define ellipse, okay? So ellipse is a set of all points in a plane such that the sum of the distances of two fixed points in a plane is going to remain the constant, right? Or the two fixed points are called as a focus, right? And since it is a 2 points, so the plural of focus is basically foci, okay, of the ellipse. The constant, which is basically the sum of the distance of a point from the focus on the two fixed point, is always greater than the distance between the two fixed point, okay? So this particular distance is going to be greater than s1 s2, okay? We'll see this particular relation will hold true, okay? And ultimately we'll see that this particular relation will turn out to be 2 times of a, right? But we haven't defined what is a, so I'm not telling you about this relation right now. Okay, the line segment through the focus of an ellipse is called the major axis. So if I try to draw the line segment through passing through the focus of the ellipse, it is called as the major axis, and the line segment passing through the center and is perpendicular to the major axis. So sorry, and the line segment passing through the perpendicular direction to the center is the midpoint of s1 s2. So this is the center, which I'm denoting by, let us say the center is denoted by point C, okay? So I'm denoting the center by point C and is perpendicular to the major axis. This is called as a minor axis, okay? This is called as a minor axis, okay? So this is how we define the ellipse and the following geometrical uh, axis, okay? So the major axis and the minor axis are two important axes of an ellipse, right? And the endpoints at the of the ellipse, which is intersecting with this major and the minor axis, are called as the vertices of the ellipses, okay? So this particular point, this point, this point, and this point are known as the vertices of this ellipse, right? So this is how the ellipse is defined, right? Now we are interested to derive what would be the standard equation look like, okay, or standard equation of ellipse look like. So let us discuss about the standard equation of an ellipse. Okay, so let us discuss about the standard equation of ellipse. So as we defined ellipse in the similar manner, let me define the coordinate axis first of all, okay? So let me take the coordinate axis. This is my y axis and this is my x axis, okay? This is my x axis and this is my y axis, okay? And let us say I define the focus or the foci of the ellipse at some point on the x axis. Therefore I mean to say that the x axis is my major axis, right? So let us say these 2 points are basically given as c comma 0, and let us take a symmetrical case on minus c comma 0. That means center is going to lie at the origin 0 comma 0, right? Now if I try to draw the ellipse with this to focus, the ellipse is going to look like this. So any point on the ellipse, right, is going to have a constant distance from the focus, so which I can uh, okay, so this is my point P. Okay, just try to ignore my way of drawing because it's difficult to draw using this pen and this board, right? Anyways, so this is my vertices, okay? So let us call this as A2 and this is called as A1, right? So these are the vertices of this ellipse, right? Now, what we have already learnt is that according to our definition of an ellipse, we have seen the sum of the distance of any point on the ellipse is basically going to be constant, right? And let us call that constant as 2 times of a, okay? So let us introduce some notation over here that the constant value we are going to get is some value like 2 times of a, right? You can call it a, but it's up to you, right? How you define it, right? Now if I use a distance formula to find out the distance of this point P from the focus, since we know the coordinate of focus, so this is going to be x minus c whole square plus y square and square root of it plus square root of x plus c whole square plus y square is going to be 2 times of a. Now please note that 2 times of a should be greater than 2 times of c, right? Because I have already said that this particular distance should be greater than the say focus distance, the focal distance, right? Or the distance between the two focus, right? Anyway, so we have this particular thing over here. Now if you're trying to simplify this part out, so x minus c whole square plus y square minus x plus c whole square minus y square would be equals to minus of 4 times of cx, right? What I'm doing over here is that I'm trying to take the square on both the side and simplify this expression, right? Okay, so we will have this following relation hold true, right? And therefore, let us call this as equation number 2, right? And let us call this as equation number 1. Okay, so what I have done over here is that this particular relation, or let me put a bracket over here, right? That is easy for you to understand. So what is this distance is this particular distance, that is a so if I take up any point and take the subtraction or the difference of the distances, then that distance will come out to be minus of 4 times of cx, right? That is how the distance will be coming out, right? But if I divide this first equation with the second equation, what I will obtain is that I will obtain a x square, oh sorry, I will obtain x minus c whole square plus y square and square root of it minus minus, because I'm using the rationalization concept, so minus square root of x plus c whole square plus of y square. What I'm doing is that this particular expression can be written as this particular expression multiplied with the negative times of this particular expression, right? So when I'm dividing it, the positive sign will get cancelled out and the negative sign will remain after, right? So you can try to do this, because this is something like a square minus b square, which I'm writing at a plus b into a minus b. This is what I'm doing over here, right? So you can follow the steps by yourself. Okay, so these are the following steps, and then this will be equals to 2 times of cx by a, and there will be minus sign, right? So this is how we will have the relation, right? Now what I can do over here is that I can do one more thing, that is x minus c whole square plus y square and whole square of it is equals to a minus cx upon a, right? We'll have this relation because so what I'm doing is that this I'm taking this expression on the right hand side, I'm trying to replace this with some value a, right? Okay, so um, so this particular thing will become like this, and now we can simplify this expression further to get an expression like x square by a square plus y square upon a square minus c square is equals to 1, right? This is how we'll have from this equation. Okay, is this clear to all of you? Right, this derivation is quite interesting, especially if you are uh, carefully observing this way of how we are deriving this expression, right? So on simplifying this, we'll finally reach to our conclusion of this kind of equation. Okay, now once we simplify this expression, now our next task is basically to introduce the concept of eccentricity, right? So what I will do over here is that I will assume that a square minus c square term is equal to some other constant, that is b square, and this is how we get the standard equation of an ellipse, that is a square plus b a square x square plus a square plus y square by b square is equals to 1. This is how the standard equation of an ellipse looks like, right? Where the value a is greater than b, that means the ellipse is having the major axis to be the x-axis, right? Now it's a second degree equation with the power of x and y are both even, that means it is symmetric about both the x and the y axis, right? And the entire curve is confined within the rectangle which is bounded by, so I can confine this entire curve inside this boundary, right? Okay, so inside this rectangle the entire curve will lie inside, right? So it is bounded by the curve where this particular point is plus a and this particular point is minus of a, and we call this particular point as a square minus c square, so that means 0 comma b, and this is as 0 comma minus b. Okay, so the in this particular rectangle this particular entire curve is confined between, right? Now as we have already discussed about in the concept of a conic section, we have been discussing with eccentricity, right? So eccentricity is going to give me the measure of, so eccentricity of any curve will give me the measure of how the degree of flatness of an ellipse is defined. Okay, so degree on so eccentricity for case of a ellipse is basically going to define me the degree of flatness, or how flat the ellipse is going to look like, right? So this degree of flatness is basically given by the eccentricity, and it is defined as c upon a, right? So therefore we will define this distance as OF1 upon OA1, right? So distance of the center to the focus divided by the distance of the center to the vertices, and this I will observe. And if I take e square on both the side, then this is going to happen is equals to c square by a square, and that I can write it as a square minus b square divided by a square, right? Which will turn out to be So this will turn out to be that eccentricity is going to be square root of 1 minus b square upon a square, 1 minus b square upon a square. Okay, this is how the eccentricity of an ellipse whose major axis is going to be x-axis is going to look like, right? So hence the ellipse will get thicker as I make this eccentricity go towards. So if you try to observe the careful notation over here, what does this mean? That since the ellipse is like this, that means if the eccentricity is very small, that means the distance of the center from the focus divided by the distance of the center of the vertices is going to be very small. What I mean by that, this particular distance is, if this is larger than this distance, then it is going to be very flat, whereas if this distance is almost comparable, then it is going to be less flattened, right, like this, right? And if my eccentricity becomes exactly equal to 0, that basically means the center to center distance, okay, and the center to center, the focus distance is going to be 0. That means it is a case of a circle, right? So if my eccentricity is going towards 0, that also means that my b will tend towards a, right? My b will also tend towards a, because I have to have this 0. That means b is equals to a, right? That means that only happens in the case of circle. Okay, also in the case of circle, the center of the circle is the focus of the circle. Okay, so the two foci come closer and coalesces to form the center, and that means the focus is the center itself, and that is the case of circle, right? So I hope you are able to understand this particular thing, right? Okay, so two important note over here is that the two ellipses are said to be similar if they have the same value of eccentricity. So if I have two ellipses and they are similar, that means they have the same eccentricity, and the distance of every focus from the eccentricity of the minor axis is equals to a, as b square a square e square is equal to a square, right? So from here we can also obtain one more important relation, is that we can get the relation of b square is equal to a square e square. Okay, sorry, very sorry, it should be a square, right? A square should be equals to b square plus a square e square, right? So this is a very important relation, and we'll try to use this relation in our solution of questions. Okay, so I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? Okay, so we have so far discussed about how we can get to the standard equation of an ellipse, right? So far this part is clear, right? So we have discussed about the standard equation of ellipse, and we've also solved about what is the basic definition of an ellipse, right? Now, along with the center, one more, along with the focus and the center, one more line is going to be very important. That is going to be the directrix, right? So similarly, in case of an ellipse, in case of an ellipse, the directrix is going to be this particular line, which is going to lie outside. So there are some line which is defined like this. So the direct, it is possible to define two line at x equals to plus or minus a by e. So this is the x equals to plus a by e. So x equals to plus a by e is the one of the directrix. Okay, is one of the directrix, and x equals to minus a by e is the another directrix, right? Okay. So since there are two focus, this will also have two directrix. Okay, so this is going to satisfy the relation. Let us say the p2 perpendicular distance of this point p on the directrix is going to be m. So that means we have already discussed this, right? So pf1 is going to be e times of pm1, right? And similarly, this particular distance, the second focus, so pf2 is going to be e times of pm. Okay, so these are the important relation that we already discussed in our conic sections, right? So in the case of an ellipse, we'll have two focus and two directrix. Okay, so I hope this is clear to all of you, and from here we can also prove that the pf1 plus pf2 is also equals to 2 times of a, right? So if we recall from this relation, so from here, if I want to find out what is the distance of pf1 plus pf2, that is going to be e times of pm1 plus pm2, and this particular distance of pm1 can be written as the directed distance minus the distance of that x coordinate of the p point, right? So that is going to be a by e minus of x1 and plus a by e plus x1. Okay, and if I simplify this expression, this x1 and minus x1 will cancel out, and we are having the expression to come out as 2 times of a is 2 times of a by e, right? So this will come out to be, oh sorry, it will come out to be 2 times of a, right? Yeah, e will also get cancelled out, so it will come out to be 2 times of a, right, which we already discussed. All right, Is this part clear to all of you? Okay, so these are the basic definitions of how we define the geometry of the ellipse and how we also get to the standard equation of the ellipse from this following geometry. Okay, so this is how we derive the expression of the standard equation of an ellipse, and this is how the eccentricity is defined. So I hope with this particular idea you can now move on to discuss about the general or the terminology regarding the ellipse, right? Is this part clear? So once we have this, we can also move our ellipse to a arbitrary center that is having the center as h comma k. Then in that case, the equation of the ellipse will only get shifted with this particular notation, right? So if my ellipse is having a center h comma k, then the value or the equation of the ellipse would look like this, right? So in this case, our center is not the origin, so it is basically shifted to h comma k. Okay. All right, so this is how we define the ellipse, right? And some of the basic terminologies regarding ellipse are that, so if I consider our standard ellipse, that is x square by a square plus y square by b square, if this is our standard ellipse, right? So, and let us consider the case of when your a is greater than b. So in this case of standard ellipse, so let me try to draw the ellipse over here, right? So very important thing is that once you draw the ellipse, please mark the focus. Okay, the focus point are going to be ae comma 0 and minus ae comma 0. The center is basically 0 comma 0. The vertices are basically minus a comma 0 and plus a comma 0. The other vertices are 0 comma b, and this is going to be 0 comma minus of b, right? Okay, so this is how the ellipse will look like. And also we have the directrix, two directrix at point x equals to a by e and at point x equals to minus of a by e, right? This is the two of my directrix, right? Now any chord passing to the focus is called as a focal chord. Okay, that we have already seen in case of an parabola. Okay, so any chord passing to the focus is called as focal chord, and in the similar manner, if it is perpendicular to this major axis, then it is called as latus rectum. Okay, so the focal chord which is perpendicular to the major axis is called as a latus rectum. Okay, it is called as a latus rectum. Okay, so these are the basic terminologies, and if I take up any chord which is perpendicular to the major axis, it is called as double ordinate, right? We have already discussed about this, similar to the concept that we have seen in our parabolas lectures, right? So these are the basic terminologies regarding an ellipse as well, right? And from here we can also find out the latus rectum length as well, right? So if you see the length of the latus rectum, it is basically the 2 points. So this particular perpendicular distance, we have to basically find out this particular distance and then multiply by 2, right? So if I put in the general equation of ellipse at x equals to ae, then my y will come out to be, so if I put x equals to a, the y will come out to be 1 minus, so y will be coming out to be 1 minus b square by a square, right? So this is how y would look like, right? Or specifically y square, right? Yes. So this is going to be, so y from here will have it um, as plus or minus b by a, right? So y will have as plus or minus b upon a, right? So from here we can sorry, b square by a, right? So we'll have this one as is to be b to the power 4, I think. Yes, it should be b to the power 4, right? All right. So yes, because y square by b square will come out, and that will make it b square b to the power 4. So I'm jumping up steps, that's why I should write over here, right? So y square by b square is equal to 1 minus b square by a square, which will come out to be b square by a square. So from here y square is equal to b to the power 4 by a square, and y will come out to be plus or minus b square by a, right? So once I have the y coordinate, then this particular distance is done. So now, so from here, the latus rectum length will turn out to be 2 times of b square by a. So this latus rectum length will turn out to be 2 times of b square by a, right? So we have now the latus rectum length, right? And it can also be written in terms of eccentricity, that is a times of, or 2a times of 1 minus e square, 2a times of 1 minus e square. Okay, so therefore this is the simplest way to also take this particular part, right? The length of the latus rectum is 2b square by a, or we can also remember it as minor axis whole square divided by major axis whole square, right? So because if I take it 2b whole square divided by 2a, this is going to be similar expression, right? So the length of the minor axis is 2b and length of the major axis is 2a. So length of the minor axis whole square divided by length of the major axis. So this is how you can remember this formula. Okay. Is this clear to all of you? Do let me know in the live chat if you have any issues. Okay. So this is part clear, right? Great. So I hope you are able to understand this concept, and we will try to solve some problems, and then your all these concepts is going to be very clear, right? So in the similar manner as we had for the major axis being the x-axis, we can also have another ellipse where the major axis is a y-axis, right? So what happens in that kind of ellipse, I'm not going to show you that particular derivation again. So if I have the case when my b is greater than a, so the y-axis is the major axis. Okay, so y-axis become the major axis. Okay, okay, so the y-axis becomes the major axis, right? And all the results that will be holding true, only the change is basically you will have the switch between the two axes. Okay, so the only x-axis results will get now switched to the y-axis results. Okay, so I'm trying to show you the results in form of a picture over here. So you can take the understanding over here is that the ellipse is now going to have the y-axis as the major axis, so it is going to look like this. Okay, and in this case your centers are going to be center is going to be origin, the focus is going to change to the y-axis coordinate, that is going to be simply your point S, that is 0 comma BE and 0 comma minus BE, right? So this is how the change will look like. So I have already listed down that what happens in which case. So in our case, when x-axis is the major axis, this is the following condition, and in the case when the y-axis is the major axis, these are the following condition, right? So please take a note of this particular thing so that you understand the things and you can interpret the result, right? Okay, is it clear? So what you see is that there is only a slight change, just your x-axis result becomes equal to the y-axis results. Okay, so in case of the shift of the major axis from x-axis to y-axis, the results will also get shifted by that particular thing, right? Is this part clear to all of you? Is this part clear? All right, so now I would like to discuss about one important problem, and then we will try to conclude with our discussion. Okay, so there are some simple problems, we can also try to solve it, but let me start with a very interesting problem of the how the locus of an ellipse can also be obtained, right? So, and it is a bit practical. Okay, so this is a more practical way of obtaining the equation of an ellipse. So you can see with this question, it is said that a ladder of 12 units length, it actually slides along a vertical plane with its ends in contact with the vertical wall and a horizontal floor along the x-axis. So you have to find out the locus of a point on the ladder which is 4 units from its foot, right? So what you have to find it out is that you can approximate this case with a 2D case where this x and y axis are basically the two vertical walls and your ladder is something like this, right? So let us say the ends of the ladder are a and b, right? We will take up a distance which is 4 unit from the foot. So let us take this distance of point P, which is that basically this PB distance is going to be 4 and this AB distance is basically going to 12. Okay, so this is the condition of the problem is given to us, right? So with this particular condition, you have to find out and write down the locus of this point P. Okay, so you have to find out the locus of this point P, right? So how will you do it? It's quite a simple problem. So let us consider these points as a comma b and this point a as 0 comma b. Okay, so the entire distance, that is I will have a square plus b square is equal to 12 square, like this is my first equation, and also I have that is pr, or sorry, this BP, right? BP upon AB, this is basically um, 4 upon 12, which is basically going to be 3 units, right? And in a similar manner, if I consider this unit as 1 unit, then this is going to be almost 3 times of it, right? That is how the distance is divided, right? So from here, what I can also talk about is that, so So this I can also give the another relation is that I can give the relation that is upon PA upon PB is going to be, so PA upon PB, so this particular length is 4, this is going to be 8, right? So I have made a mistake, it should be 2 times, right? It should be 2 times, right? Yes. So in this case, PA upon PB is going to be 2, right? So PA upon PB is going to be 2 because there is 4, this is 8, right? And then I can denote my H is equals to 2A. So H equals to 2A by 3 and my K will be equals to, so this particular point I'm just using section formula. So H equal to 2A by 3 and K will be equals to B by 3, right? So these are obtained by using section formula, right? Okay, so section formula I'm using it over here to get this result, and then if I take the value of a square plus b square because we know it, so a becomes 3h by 2, so that it will be 9h square by 4 plus of 9k square, that would be equal to 144. So if you simplify to get to the locus, because we know in the question of locus we have to just at the last step, once we got a relation in h and k, we have to replace that h and k with x and y, right? So I will have x square by 64 plus y square by 16 is equals to 1, right? So this is the required equation of the that particular locus. Okay, so this is the required equation of the locus, which is basically an ellipse. So what you understand is that if I take a point such that it is not at the center, not exactly at the center, then that particular point locus is going to be an ellipse, right? But if I take the point at the center, you will see that the locus would almost become like that of a circle. Okay, you can try that up. Okay, you can try that up, right? So that will become equal to the locus of a circle. So if I take a point which is not in the center, it is an ellipse. If I take a point in the center of the ladder, it is going to be a circle. Okay, so this is a very important result that we can see over here from this particular problem, right? So I hope this question is clear to all of you, right? So now what I can do is that I can give you some problems to practice as a homework problems. Okay, so please try to go through the basic lecture notes and try to solve these problems. Okay, and do let me know whatever answers you are getting in the comment section. Okay, so once this lecture is over, you can definitely let me know the answers you are getting in the comment section. Okay, so these are the question, you can try it up, and also if you are having any doubts in any of this question, do pin me up in the telegram group. Also you can let me know in the next class, so maybe in the live chat you can let me know that I am having a doubt in this particular problem. Okay, and we can definitely work out on that problem itself in the live class. Okay, so with this thing I would like to conclude this first lecture, which is basically a basic lecture on the general equation of the ellipse and learning about the geometrical terminologies. So in the next lecture we are going to move or dive deeper into this concept of ellipse. We're going to see some more other definition, what happens for a general ellipse, that we have taken the case of standard ellipse. That means our x and y axis becomes the major axis and the minor axis. What happens if I take up any random line as the major and the minor axis, right? So in that case, how we get to the equation of ellipse, or what is the standard equation of ellipse going to look like, right? So from there we will try to also discuss about the general equation of an ellipse, right? And along with that we'll discuss about certain concepts like that of an auxiliary circle, eccentric angle, and all sort of things, right? And some of the important properties regarding ellipse, right? So all those things is going to definitely come up on this particular platform. So if you're new to this particular platform, please subscribe to channel and hit the bell icon, so that whenever we are live on this platform you get a direct notification. Okay, and if you have any doubts, any question, you can always pin me up and let me know your comments and questions. Okay, and whether you're able to understand this series or not. Okay, and definitely do let me know what is your opinion on your JEE Mains revision series. Okay, so do you want the JEE Mains revision series or not, or should we bring it or not, right? Because your JEE Mains exam is very near, right? So in the January you will going to have your JEE Mains exam. So before that, do you want a revision, or do you want me to continue with this particular lecture? I'm definitely going to look out for your opinion in the comment section. Okay, so with this, thank you, and I hope to see you soon in our next live class.